Really you're an enabler. PhyTech's enabler for the advancement of electronics technology.
I am really curious to know if you have other customers like me, because I felt like I was giving you an impossible task, but never once was there any sweat. You guys are like, no problem, we can do it. And then the speed at which you ripped out this drawing was shock.
As much as it looked like it happened really fast and there was a lot of magic happening, the collaboration that we had between our team and your team was really critical for that to be successful.
I feel like we had a good handle on the problem.
Yeah.
We just we didn't know what our solution was.
Solutionology is about being unyielding with perseverance to get to the solution.
To not give up and to constantly drive for better. So even when we deliver 100%, I want to deliver 110 next time.
And for me, the constraints of that project are the most important because that's what drives us to a solution. It's all about painting a picture and getting all the details in.
How do we develop a tool that helps share our journey, educate others, and bring more light to the realities of additive manufacturing? The Solutionology Podcast. Welcome to the Solutionology Podcast number 10. In this episode, we've got a customer joining us, PhyTech, who is an advanced electronics developer and manufacturer. They focus on this thing called SOM, System on Modules. And Sarah's joined us. Sarah's the leader for this particular project. And she came to us with a problem. And that problem was, we've got this great circuit architecture that solves some problems for our customers. Specifically, this is an EV charger. But the problem is our customers aren't connecting with these circuit boards that we have to offer. So we need to develop a housing for this device that looks like a charger, and we need it as soon as possible. So obviously, additive manufacturing swooped in, saved the day, and Sierra's going to share that journey with us, talking to us, sharing with us about PhyTech, the types of solutions that they offer, the markets they serve, and then ultimately her journey and learning about additive manufacturing and how the technology helped solve her problem in the case of this circuit architecture business.
Thanks for having me on your guys' podcast. You took something that we were making that was kind of a little outside of our area expertise. We're all electrical engineers, hardware and software, layout, manufacturing. So we're very deep in electronics. And then you guys were able to help us elevate it by providing design services and making it for us.
So this housing was designed in-house to be produced from HP Multijet Fusion using Nylon 12. Once the housing was printed, we vapor smoothed it and then finally added heat-staked inserts so that the components can be assembled as a system. The initial production was of one unit to test fit everything, and then from there we produced an additional set of units, and the whole design was intended to be produced in low volume. So we're conscientious of the installation process, designed for additive manufacturing and production. We were looking at this from a low volume production standpoint. And because it was vapor smoothed and in the hands of customers, we also dyed the housing so that it would look like an injection molded, high quality, high surface finish device.
The project we brought today, and we can kind of go through it all, is we made an EV charging reference design. Yeah, perfect. We have a slide up too of kind of what we made.
So this is Gen 1. This is a solution you were using before we supported you on the project.
Yeah, so we call this Rev Zero. We have a lot of software engineers who do zero indexing. So we call this Rev Zero. And our product is so far inside, we wanted to be able to see it. So we did a clear case. So this is made, you can probably tell, you guys know this is made out of acrylic. And everything's just written out. I think I cut those labels on my Cricut.
Wow, nice.
Very DIY. And then we actually had this showcased at Embedded World. So Embedded World is like embedded electronics. That's our show. So this is a big show for our industry. everything embedded. So we showcased this EV charger reference design at Embedded World, which was held in June this year. It was a hit. It was really easy to talk to people about. You can plug a charger in. I mean, some of you watching may wonder why there's a plug on both sides. I did. Every EV I've seen, the cable's on the charger. But in Europe, they bring the charger with them, so it's got plugs on both sides. So this is a European design. So that was something I learned through the project. So yeah, this was a successful product, and this enclosure, this RevZero enclosure, to go show customers reference design, see it in action. We were shipping it. That thing is heavy. It's like acrylic. It's big. The box we have to ship it in is like oversized. Just about fits the shipping limits. A little difficult internationally, I think. Pretty expensive.
Yeah.
So to get ready for a couple other shows and to have a reference design to work with customers with, so they can really visualize what our reference design is, I found DI Labs. So even our first conversation, I think I sent you this picture and just said, can you make this look like an EV charger, please?
Yeah, I think as you approached us, you shared with us, I think the nickname of this is the fish tank.
Yeah, we call it the fish tank. Yeah, we do call it the fish tank. Yes.
When we first talked about your project, discussed it, it's like we design all these cool electronics inside that make all this magic happen. And this fish tank design allows us to show off our electronics. But what we're trying to accomplish is we want our clients to envision what the product could look like if they were going to make it themselves. And as you're deeply ingrained in the embedded systems and you don't have the resources available to your team for the design and development of the case, that's where we connected. It's like, wow, yeah, this is a perfect match where we can support you on something that you're not able to do in-house today. And the electronic side's like, we're not developing electronics. So it was a great kickoff right from the beginning.
Yeah, and I think that the real thing we were trying to solve too was we wanted to turn this demo into a fleet of EV chargers as well. So we needed more of them and very fast. So I remember my first conversation was, hi, we have this. I need it redesigned, and I need 5 of them in 5 days. Tell me I'm crazy. And your guy Alex wouldn't refuse to tell me I was crazy. And I was like, I know that this is unreal. This is not even realistic. Make a design from scratch and print it and make me like 5, just in print time. But you guys came really dang close. Like, got me a prototype in 2 weeks from just the first contact. And I think that's really the key. You guys really delivered on. I don't know if you dropped everything you were doing to work on this, or I don't know what the magic was, but yeah, maybe you can even tell us.
And as we're acting with, our day-to-day focus is new product development, especially when it comes to developing, physical product for assembly or parts or look and feel, whatever it may be. We're accustomed to the ambiguous request of, we need this thing and we don't know what it needs to be, but can you make it for us? Can you make it for us fast? Because that's really important for our project. So we went through our standard new product development process, and we have industrial designer on our team. So the first step is, what is this thing going to look like? Because the person who designs the functionality of a product isn't the person who's going to design what it looks like, because those are counterproductive in most cases. So we made some sketches. So he said, to us, this is what an EV charger should look like. I think we shared the sketches with you.
Yeah, you did. Yeah. I think we immediately were like, oh, yeah. But I can see it even has ports on the bottom, too. I think in your initial sketches, too, you guys were telling us, like, hey, we need to plan for how your power is going to come in, because you can't just be having drill holes in the side, hack it up kind of for your demo and whatnot. So I thought that was really nice.
And so we did a little translating from your request to what you were really asking for, and it's something that's a significant challenge on product development, because it's like from one point of view, there's a request coming from that perspective, and then we're trying to convert that request and translate it into what's really required. What are they really asking for? They're asking for it based on their known perspective, and then it's like we've got to convert that into what's actually possible, so that we're not limiting them with their perspective, but we're going to enable them with what's possible.
Yeah, I remember even on a call one time, you're like, well, we need to do a cable clamp. And I was like, cable clamp? And I like Googled it, and I was like, oh, okay.
Those pesky cable glands.
Or cable gland, that's what it was. It was a cable gland. And I think I remember it because I'm like, oh, it kind of like clamps the cable in there. But yeah, I had to look that up. So you don't know what you don't know. So you guys introduced us to quite a lot of things. I am really curious to know if you have other customers like me, because I felt like I was giving you an impossible task, but like never once was there any sweat from your team at all.
You're not alone.
Yeah.
You're not alone at all.
Yeah. You guys are like, no problem, we can do it. And then the speed at which you ripped out this drawing, I was shocked. Like, I think it was within 3 days I had a drawing, and the timeline started to be a little realistic. So it was like a week of just kind of going back and forth on the design, which you brought in an industrial designer even. Like, I don't even know how you guys fit the time in. And then the next week, I think you were printing. All right. So I feel like this is a good time for you guys to explain to the world what you did. And even to Phytech. Tell us how you did it.
First week felt really slow as we were getting the requirements from you, and then we're going back and forth like, how do you want to assemble the electronics within the device, and how do you want to stack them so you have access to the things that are critical, but it's also easy for you to do, because once we get this to you, you've got to get everything together, and then you've got to get it to the show, and it's got to work, and there's no opportunity to have a failure here and still meet the timeline. So that first week, it felt really slow, but being very planful and collaborating through that process, it made it really easy for us. So you brought the information, and then we were able to collaborate in real time, make sure our electronics were located right, we could assemble it, and for us, it went pretty smooth.
Yeah, so the housing is really designed to hold and mount the internal components and be able to do so that it's easily assemblable. And then for teardown, it can be easily torn down. So it was designed as if it's a final good, even recognizing it's a prototype. And being able to work with your team and understanding the constraints that you have and the objectives you had for each of the boards, the spacing, the panel, allowed us to really tailor the design specifically for your needs. And not in all cases are the projects that well defined initially. So as much as it looked like it happened really fast and there was a lot of magic happening, the collaboration that we had between our team and your team was really critical for that to be successful. And just understanding all those details that clearly you and the Phytech team had lined out really, really well. So that appreciated the level of detail that the team had, and that's what helped make this thing successful for sure.
Yeah, I mean, I feel like we had a good handle on the problem.
Yeah.
We just we didn't know what our solution was. So that's where you guys really completed the project for us. Because we have, for us, that 10-inch display in there, really high quality display from Lincoln Technology Solutions. But I wasn't really sure how to mount it. There's no mounting holes. So to me, it's like our SOMs that you need to mount down. There's always the holes. They're M.3s or M3s and 5mm standoffs. It's very straightforward. But when you're holding the displays, you're like, how is this? And then you have all the cables that need the pin 1 alignment. And then on top of it, so Phytech makes the low-level electronics boards, the stuff, the HMI, things that run Linux. And then Texas Instruments, they made that, there's a picture of it, that big board on top. You actually can't see our product, our Yeah, so that's our product. But the one in the slides on the screen there with the really tall components is bigger than it looks. So when you have it in real life, it's quite tall. So, and then the relay there accepts main voltage. So kind of dangerous levels. So for us, that's kind of a risky situation. So it just seemed like it might have been kind of hard to get all the pieces together. Because if I think about it, it has our system on module. We have our development kit carrier board. We have 2 expansion boards. One of them is like an M.2 slot that plugs in the back. So then we have another expansion board that comes off the side. And then we have a cable that plugs into the power board, the TI board. And then we also have the screen. So that's like 6. I just listed out 6 parts that you guys had to assemble together. So I think we just gave you the mechanical files. So the most mechanical we do is a 3D flow with our SOM and carrier board. Make sure there's no conflicts and whatnot. So how was it working with like those electronic files? Were they too detailed? Were they big, bulky? Because there's a lot of parts on a little tiny board.
Those were big files. Yeah, those are big files to handle. But the fact that you had all that, allowed us to work in 3D with relative ease. We knew we knew where everything was. We could locate it. And then you also sent us the physical parts before parts were printing. You sent us physical parts so that we could validate, the digital and physical and get perspective on where parts are going. So having all that information in front of us as we're designing, it gave us the keys to, package it all in the right way so that the final design that we sent you for Rev 1, it's on the right side. We assembled all the parts before we shipped it, so we knew that it was going to work, everything fit, and it's kind of like a training piece. It's like, okay, this is how parts go together, because they've never seen this before. We just saw it for the first time 15 minutes ago. So we're going to send it to you assembled so that you don't have to figure out how to get all these parts together.
I mean, it worked out great that way too, because when we got it, picture, take the first layer out, picture.
So, for me, unless I knew this story, I wouldn't have suspected that Phytech would need a housing. So I'll explain that. So Phytech makes the SOM boards, and I see it as the heart to the system. And the brains. It's also the brains. So it's the heart and the brains to the system. That SOM board goes on a carrier board. That carrier board connects a bunch of things together, and then there's another board or 2 that then controls the high energy power and the other aspects of the system. And so there's like all these components coming together to make this thing a whole working system. And it's really interesting to me that Phytech said, you know what? Actually, I'll take that one there. Phytech said, you know what? In order to connect the dots for our customers who are interested in these hearts and brains, I need something that they can interact with, but I want it to look like a real charger. Because you had something they could interact with a fish tank, right? Has there been a change, and I think you said this, but has there been a change in the way the customers interact with this device versus the way they interacted with the fish tank? And has that driven anything different for Phytech or for your project?
Yeah, I think mostly I'm a visual person. Most of the engineers I work with are visual, and they want something that
Looks and feels.
Yeah, that's part of the experience, right? It's all about experience. I think that having your guys' case and your expertise levels up the experience, makes it a better experience when you're working with it, so that you can really tear down and see what you want to make. It gets you one big step closer to where you actually want to go. So when you go into a meeting, you're trying to pitch the product, you have something you can show, and something that maybe people that aren't engineers can understand, and gives you like a platform that you can look at.
Now that we've learned a little bit about the problem that DI Labs helped Phytech solve, we're going to learn more about embedded electronics and specifically system on module components. And these are such a critical component of electronic systems. You may not think much about it as you're interacting with all the various electronics throughout your daily lives, But Phytech's system-on-module components and their other embedded system components are such critical aspects of electronic systems. So we'll learn more about that. I learned a lot through this discussion, and hopefully you do too.
What is a SOM or system on module? Because that's not a common word that I think people normally know as an engineer. Maybe if you work specifically in embedded systems, you've heard of a system on module, a SOM, or a system on chip, a SoC. So we have a picture up here with one of our system on modules. We make a lot of different types. So I have one with me right here. This is a Phi-Core AM6-2 system on module, and it has connectors on the back. So normally, you can think of a SOM like a motherboard for embedded systems. So we take everything that's common to an embedded system, so any embedded electronic, and we modularize it. So that means if you were going to make an embedded system, you would need a processor, some RAM, flash, power management, maybe some connectivity like an Ethernet PHY, and then we put connectors.
So as a customer of Phytech, if I were looking at purchasing or speccing a SOM, I would spec it based off of my application, and there would be, I guess, different processing speeds, different RAM memory amounts. Is that how it works?
Yeah, so I guess maybe I'll tell you a little bit about our customer base as well. So do you guys know what embedded systems are, or have you heard of that term before?
We have heard the term.
Yes.
Okay.
Probably know enough
Yes.
to be dangerous.
Yeah.
Okay, yeah. So most people don't know what an embedded system is because they're embedded in our everyday lives. So our customers you probably interact with SOMs and embedded systems every day in your life. We're in a recording studio right now, and I'm like looking around at all the cameras and the microphones and the audio and our lovely helpers here that are controlling everything. Those are probably all done by an embedded application. So normally when you think about it, it's almost like everything that needs a computer that's not in an actual computer or a laptop or a cell phone. So I came here from Bainbridge Island, and I interacted with a lot of embedded systems traveling. When I paid for my ticket for the ferry, when I got on the subway, when the doors opened and closed, the little screen that tells me when the train that I just missed when the next one will come, and whatnot. So basically what we do is we try to make it easier for people that have an idea or need to make an embedded product. We make it easier for them to come up with a design and get it to market quickly. So the things I mentioned about, like, we use the processor, we take the processor, the RAM, the flash, the power, and the connectivity. That takes us probably 1 to 2 years to get it right. So if you leverage our system on module, you can get your product to market in much less time. You don't have to spend that 1 to 2 years getting everything we know you probably need to get your embedded system right. So you can just focus on what your application needs. If you need a specific sensor, so if we think of maybe like a camera, maybe you'll put your specific sensor down, and then you'll hook it up to a computing platform, and then send images over the cloud. So your steps would be much simpler. You just design a carrier board card around our system on module, which could be 4, 6, 8 layers, where our SOM is like a 10 to 12 layer board. And then we try to take care of some of the complex production, like BGA components. If you guys want to take a look, I have some more over there, and you can flip it over and see how tightly packed things are.
So your boards are incredibly dense, and that simplifies the carrier board, which allows customers then to have a simpler solution. And I guess, really you're an enabler. Phytech's enabler for the advancement of electronics technology.
Yeah, that's the problem we're trying to solve, is you have an idea, but you don't know how to make it. We don't want you to have to try and make it for 2 years. We just want you to be able to get your idea to market and utilize our expertise. I always like to think of Phytech as actually being very embedded. We're not doing anything flashy or fancy, really. We're just doing the basics, and we're trying to do them really well at very high quality. And then I think the other thing that's pertinent just in the times we're in right now, everyone's got a feel for supply chain shortages, component EOLs, not being able to get components. If your critical components are all in a module, Phytech will take care of the headache, the heartache, the tears. But stuff, in all seriousness, in general, process technology changes, especially for things like RAM. So DDR3, DDR4, LPDDR4, those go end of life every 2 to 3 years. So we work with suppliers like Micron on replacements. We qualify them. So that's another step that you can kind of skip later down the line. Not really something you notice until it hurts you, but just another little advantage. So we try to do all the stuff no one wants to do really well. And that's solving a problem in itself.
It's really neat to hear how you're accelerating your clients' ability to take action. And when starting a complex project where you need a solution like this, I think the tendency is to start from scratch. Yeah. But for those teams who don't have the resources available, with technical team members or the capability in-house to develop this and spend the time, it's remarkable. Saving 2 years off of a product design and having something that you can plug in right off the shelf or have it slightly customized for your application, that is really cool. The time savings is huge.
Yeah, and that's the thing we do too with customization. So we have in-house production. So we make these system-on modules at Phytech. Our production facility is in Mainz, Germany. It's right outside of Frankfurt, and we've had production capabilities for over 30 years.
Wow.
So being able to produce our own product, you get that feedback of manufacturing into the actual design. You're constantly trying to improve and learn from it. And then the best thing for our customers is being able to offer the high mix, low volume. So if you have a project and you're only going to build 100 a year, we still treat you as we treat all of our customers, and we group everybody together so that we look like one big customer. So you get the advantages of being a big customer even at small volumes. So we serve customers that do 1 unit ever, all the way to 100,000 units a year. We have solutions for pretty much everybody.
Well, it's really neat to think about that, and thank you so much for sharing, the details of Phytech and your place in the embedded world. Clearly, you're a leader in that space, and I don't know that I ever really thought of how an embedded system is getting me from point A to point B. In your case, from Seattle area to here in Minnesota. Now that we've taken a deep dive into embedded electronics, we're going to zoom out and learn about Sierra's journey, learning about additive manufacturing, and specifically that injection molding is not the only option. So she's going to share with us her fascinating journey, learning about additive manufacturing, and then ultimately how we were able to help her at DI Labs identify the right solution that met her budget requirements along with her timeline. And, the journey is interesting. It's one that we all face as we're launching new products. We have a great deal of depth in a specific area like Sierra and Phytech and embedded electronics, but they're not real familiar with additive manufacturing. So they leaned on us at DI Labs to help them identify the right technology that provided them the best solution for their enclosure that met all their requirements and also met the timeline and budget. I hope that there's some key takeaways for you here. And, this is an area where we excel. We specialize in additive manufacturing, and we're here to help you through that journey so that you can speed it up and hopefully make less learning mistakes, less learning decisions.
The other thing I wanted to say, too, was when we needed to make more, we were all like, okay, so we have to injection mold this. We need a mold, and we don't want it to look 3D printed. We don't want it to look like an EV charger, so we have to injection mold this. I don't know anything about injection molding. So just kind of being green there. I went around and was asking, I was at a technology show, like an industrial manufacturing and technology show in Chicago. And there's all these CNC milling machines, injection molding. Like it's a very big show. And everyone I was talking to, I was like, yeah, I got this demo, crazy timeline. I need to figure out how I'm going to get it injection molded. And they're this laughed at me, got laughed at quite a lot. Very helpful people educated me quickly about injection molding and how much that costs and how many pieces you're normally doing if you're injection molding. And it's not 5. Yeah. So then they told me I need to 3D print it. And I was like, I can't. Our 3D printer is like this big. The bed is this big. And yes, we know how to make little parts here and there for demos and whatnot with our 3D printer, which is just, what type do I have? I have a Prusa 3D printer.
FDM, yeah, filament printer.
Okay, so we have these filament printers. We use PLA. You can tell they're 3D printed. And the size, like the display alone in the EV charger is 10 inches diagonally. So any pieces that we print, like we tried to do a little cover for our fish tank enclosure. It's 2 pieces glued together because of our print bed size. So when these companies were telling me about injection molding and how I needed to 3D print, I was like, it's not the look I'm going for. I want like a very polished look. And they're like, yeah, industrial 3D printing. And I was like, I don't know what you're saying. So then there was another hall that was all additive technology. And I walked in and I think I could hear the sounds of like you made it. It's what you've been looking for. You've just been looking for a couple days with no luck, but it's here. And I was just walking around, and so these were people selling their printers, right? Mm-hmm. I work for a company of 25 people on Bainbridge Island, and our lab is already full of electronics equipment. Like that's heat guns, soldering irons, microscopes, baking ovens for components, very electronic focused. So I know for a fact we're not getting one of these, which I'm hoping to see when I tour you guys' facility. We will not be getting one of these printers. But I walked by the HP booth, and they had, and like I double took because I was like, that can't be 3D printed. It was like a little medical device. It was a medical device that I could open up, and I think it was painted. It's like vapor smooth and painted. And one of the apps engineers there took me to a wall of car parts, and I couldn't believe they were 3D printed. They were like, they had textures on them. They were different colors. They were shiny.
So now that we've heard Sierra's journey and heard the sound of the angels opening the doors to the heavens of technology, specifically additive manufacturing, now we're going to talk about the parallels that exist between Phytech and DI Labs, and specifically the way that Phytech serves customers and engaging with them not only on a product manufacturing level, but on a design and solution level to help better understand the problems to be solved, and then providing the best solutions to stay within their development budget and, most importantly, their timeline. So in a lot of cases, we're hearing from Sierra that they're able to shave as much as 2 years off of a project because of their development on prototypes and leveraging their embedded systems platform. You know, there's a lot of similarities in the way that DI Labs serves our customers, and in this case, served Phytech, to accelerate innovation. We use additive manufacturing and product design, but there's such an important aspect to being able to bring products to market sooner. I think that that's underappreciated. In most cases, companies are mostly focused on budget. But time, budget is connected to time in a really big way that is intangible, but there's no doubt that it's more critical, has a bigger impact than we often realize until it's too late, and then time's gone. That's something that, especially hearing more and more about the Phytech story, there's a ton of parallels between how you help your customers by enabling, you're doing all the heavy lifting behind the scenes, and then you're making the solution so they can simply plug and play, right? And then accelerate the innovation for their customers. And we're doing the same thing. So that's one of the reasons I think it was such a good mix for us to support you on this project, because we're helping you in the same way that you're helping your customers.
Yeah, I feel that too. Like when you guys explain your business, or I met some of the team members at DI Labs yesterday, and I felt like they were my coworkers. And even though you guys manufacture different things, I feel like even though we don't use the same acronyms, we can kind of communicate, because the production process is so similar between, well, not exactly similar, but just how you produce things, prototype, and then produce in volumes. The process is very similar. It's just the terms and materials are different. So it kind of reminds me of like coding a little bit. You don't have to take a class from scratch for every language you learn. You kind of learn a language first, and then you can use the same concept you applied to write programs in other languages. Yeah. I feel like that's the coolest part, is your guys' manufacturing process.
Well, really appreciate you coming on, Sierra, and sharing your story with us, and the journey that you've had with Phytech, and also the SOM story, of all the chips that are in place, the SOM chips or SOM boards that are in place that make everything that we do a reality. And neat to think about those in terms of EV chargers, and also really, it's really powerful, I think, the idea that in order to really bridge the gap for customers with things like this, it's important that they have the ability to look and feel and interact with a device that looks like it's finished, and then that connects the dots for them. So, great experience. Probably the first time that we've experienced that level of bridge building from something as instrumental but small in the big picture as this. You know what I mean? So really cool.
We're engineers. We build bridges, right?
Yeah, that's exactly right.
But yeah, no, thank you guys. I can't thank you enough just for letting me come and get the facility tour too, and just for solving problems, I guess. You guys really nailed it, and everyone's just been really excited about the work that you do. So yeah, I hope we do more projects together.
Bring us some problems.
We live for this sort of thing. This is what gets us up every day.
Yeah. Okay.
I hope you enjoyed listening to Sierra's journey as much as we did participating with her in it. As I reflect on the project, probably the biggest takeaway for me is the power of visualization and the impact it can have on bringing a product to market and connecting with potential customers. This was a great example because Phytech develops products that are so deeply buried in systems that it's not directly connected with an enclosure, for example. But it was paramount for them to create that connection so that their customers who build these EV chargers can visualize what their device could end up looking like. So there's a lot of opportunities to leverage additive manufacturing to help maximize your business and market entry, even in ways that you may not initially think. That's my biggest takeaway. And really appreciated the opportunity to work with Sierra and Phytech on this project. And I suspect with the success that they've had, they're going to be leveraging additive manufacturing more and more to be able to drive real business results. And I look forward to being able to help them with that.